Good afternoon, dear friends. Today we are shooting a video on using the ATP 1000 tester. So the ATP 1000 tester is such a device. On top of it there is a connector for connecting cables for testing actuators, a power connector. There is a power switch on the side of it. A menu return button, a menu jump button, and an entry button. That is, if you press the knob of the regulator, a click is made, that is, there are buttons. Let's start the review. When loading the tester, such a message goes away. There are 2 points here that say that it can be used in tester mode and in programming mode. Let's look at the tester mode. So, we click on the button and enter the main menu of the tester. With this tester, you can check the actuator, check the engine that is inside the actuator, check the sensor, and you can also check the electric valve type N75. Now we will try to check the engine. So, we prepared the engine, connected it with a universal cable. There are 5 laces in the universal cable, but not in different colors. To connect the motor, the color yellow and white are required. The other 3 colors are used to test the sensors. The red wire is designed to supply the plus power to the sensor, the blue wire is for the minus power to the sensor, and the black wire is the signal wire through which data for the tester comes out of the sensor. We are not using them yet, so we have connected the motor and will enter the DC motor test mode. To do this, we rotate the control knob until the arrow switches to the DC motor test position. We press the button, and now we have entered the menu to check the engine. So, what position is intended for what? The control is the task of the PWM on the engine. Direction is the direction of rotation of the motor. And it's just the consumption of the motor at the moment, and max is the maximum current noticed during testing. In order to run the testing itself, it is necessary that here, that is, in this case, we still have the motor disconnected from the power supply. In order to run it, you need to click on the OK button. So there is another piece of the menu, which is called position. Here, when an actuator is connected to the tester, you can see the position of the actuator, while moving it, well, controlling its motor. I'll show you that too, while we just focus on the engine. So, we have a conventional motor from an actuator. In this case, well, for myself, for convenience, I soldered here, but usually white and yellow chips are connected here. So, here we have connected the motor. Click on the button. Here the launch occurred. At the moment, it was clear that when starting the current consumption is 0.05 amperes. And we begin to rotate the handle. We see that our task is growing. That is, this task means that at the moment 8% of the PWM is being issued to this engine, and we see that it is already rotating. Here we increase, it accelerates. And reduce it. We can stop it right away at this moment. Stop also by pressing the OK button. Here we stopped. Only in this mode can you change, that is, during the stopped mode, you can change the direction of rotation. So we rotate the arrow of the regulator to the right rot to us. That is, in this case, the movement will be in the right direction. We launch it again, we see that it has started to rotate in the other direction. We're going to turn it down again. That is, we see that now it is rotating conditionally counterclockwise. We change the direction, we see that the direction of rotation of the engine has also changed. It began to rotate to the right side. So, with the option when you have written of, you see the value of the current. But as soon as you click on the button, it will erase and fix the new next maximum value. That is, after each click on the controller, the maximum value is fixed, and then when you enter the control mode, it is erased again and looks for a new maximum value. Now we have already connected an actuator to our tester. Well, for example, here we took such a Honeywell actuator. So, let's go into the DC motor test mode again. So, click OK. We supply power to the tester. And we see that we have the value of position. That is, in this case, the power went to the actuator and the actuator gave us its position, that is, 27%. This position is displayed only when the actuator is powered. The fact that there is power to the actuator is indicated by this backlight on the button. That is, when there is no power on it, it goes out. When we have off, nothing burns here. The position is fixed, but in this case it will not be displayed. As soon as we applied the power, our position changed here. If I move my hand, we see that our position is moving. This function is very useful sometimes when studying a new actuator. Because it happens that we do not know what kind of actuator it is, what its limiting values are, but at the same time we can also check it. Let's say we want to control the actuator assembly. We set the position, we see that the lever has already gone and the position is changing. And in this case, we see that no matter how much more we feed the PWM to the actuator, the position no longer changes. That is, the actuator has become its extreme position. We change the movement in the other direction. Here went the actuator. We see that his position has also changed. Also consider the sensor test mode. In the sensor test mode, when we enter it, we write a type in, that is, the tester automatically determines what type of input signal we have from the sensor. In this case, it is an ADC, that is, the type of output signal from the actuator is analog. There is also a second type, this is PWM, and in English it is designated PWM. We also have two positional lines. One of them is displayed in volts, the other in percentages. If we move the lever, we see that. Well, in this case, for example, 10% corresponds to 0.52 volts. Changing the position. For example, for 49%, this is 246 volts. Now let's consider the option of testing the actuator. So in this case, we took a Siemens actuator and this is an actuator, well, we set two tasks for it. On the one hand, to show how it can be tested, and the second option, this tester allows you to adapt this actuator. What are adaptation, how to do it, now we will also see. So, we switch to the actuator mode and find the test in the list of Siemens actuators. We're coming in. After you have selected the actuator, the tester offers you a cable connection option. This is not a prerequisite, but in this way you can, without looking at the instructions, understand which cable you need in order to connect a specific actuator to our test. So, we need blue-yellow cable here. We have blue-yellow cable connected. Two variants of the testing mode are offered, manual and automatic. What is their difference? In manual mode, you can independently set the range in which the actuator will run. That is, the position you want him to go to. In automatic mode, it will automatically drive the actuator between the extreme positions. Now what I would like to pay attention to. Let's take a look. Here we have a Siemens actuator and its full range, but if we manually push it away, it is beyond, let's say, the limits of this bolt. Yes? That is, this is its full range. Now our actuator is already adapted to the specific angle in which it can walk. Let's check it out. So, we have a connection going on. This is what the tests tell us. As soon as the connection is completed, the connection is written OK. It says that the tester has found the actuator and is ready to work with it. So, the initial position of the Siemens actuator is 19%. So let's look at this menu. This means that the control line is also present here, that is, this is the value that the tester sets. The position is the value in which the actuator and the current value of the current are actually located. And max is the maximum value of the current observed during operation of this actuator. Off, and it will also change to on. This is the possibility of your control. That is, we see that at this point in time the power is already supplied to the actuator, but if we rotate the handle, it does not lead to anything. We connect, it is written, and now, changing the value of the task, we see that the actuator engine begins to rotate and moves. So, the maximum position of this actuator, you see, after which it does not go anywhere, despite the fact that you rotate the handle, is 80%. We see that in this case. That is, we remembered that the main range was the maximum right up to this point. Now we have an actuator only up to this point. That is, it has already been programmed. Accordingly, its maximum position is where it was programmed. Now let's move on to programming. So, I draw your attention to what to programming. This means that the return to the menu takes place with the help of the back. I draw your attention to the fact that it is possible to program Siemens actuators only with the presence of physical mechanical stops. That is, either when the tester is directly on the turbine and all the pull rods are connected. Either you can make it, or there are ready-made options when the limiters are screwed here and you set the desired range on them, and then it begins to adapt. I'm improvising now. I took here the usual bolt M6. I will make an artificial restriction for him in order to demonstrate the programming process. So, we go into the program mode. We are offered the option of what we will program. This is Siemens. It is written that to start the program, click OK. That is, you will need to click on the OK button. If you have changed your mind about programming, then you can simply exit this menu using the back button to the initial menu. So, we go in again and click Programming. The actuator goes all the way, finds it, returns to the starting position and stops. As soon as the LED on the button went out and this message appeared that programming is over, press the back button to return to the initial menu. So, we go in and check what we have programmed with you. Once again, the Siemens actuator. I'm about to unscrew the bolt. We don't need him anymore. So, connection takes place. Everything is ready, and now let's see. So, we see that our range has expanded to the place where the mechanical stop was located. Also, let's look at the automatic control mode. So, the connection is happening again. The activation is ready. So, when you click on the OK button, the actuator will move from the position of the minimum 20% to the maximum 80%. In this mode, we see that a current of 149 amperes is fixed. That is, this is the maximum current seen with this sudden movement. So, in this version, we saw that it is possible to expand the range by programming or adapting the Siemens actuator, as well as automatic testing mode. Go back to the original menu. Once again, I draw your attention to the fact that Siemens actuators can be adapted only when it has physical rigid stops. It's just that in the variant of a free actuator, programming will not happen for you, even if you enter the program mode. It will not find his hard stop, will reach the end of his scale at all, will determine that he did not meet a hard stop on the way, and will leave the previous value that was programmed on him. Now we will look at testing fairly common actuators. In principle, these are Heller actuators. To do this, go to the actuator mode, select the type of Heller's actuators, and we are offered a list of actuators that can be tested on this tester. In this case, there are 34 of subtype of Heller actuators. Let's see what kind of actuator we have here. This is 009228. 6 Northwest 009228. It is proposed to connect the red-blue cable. That's what we have, red-blue. I will dwell a little on Heller's actuators. In fact, there are two types of them. Rear and C rear, or one of the options, is an option when you have a board inside the actuator that controls the actuator. That is, all the tester needs is just to set the desired task on the actuator, and the actuator itself will become the desired position, and will hold it. The second variant of the actuator Heller is the option when you have divided control. That is, there is a separate sensor board that gives the tester a value about its real position. And separately, the motor, which is also output by two wires, and the control of this actuator is carried out directly by the tester. That is, he controls the motor himself in such a way that the motor becomes, or rather the actuator becomes, in the desired position. In this case, well, this particular actuator is an actuator that has a control board inside. That is, he will regulate the position himself. All he needs is for the tester to ask him what position he needs to be in. Also, the actuators that are connected by a red-blue cable, for the most part, have the ability to program the angle. So, the range in which it will be controlled. Well, that is, about as we have now had with Siemens, only in Heller actuators you can set both extreme points. If only one extreme point could be set in Siemens, then Heller allows you to do this with two extreme points. Actuators that are connected by other types of cables, they are not programmable. Using the example of this actuator, we will consider both programming and reading the firmware. Again, I draw your attention to the fact that reading the firmware, everything related to programming, with programs for Heller's actuators. This applies only to actuators that are connected with a red-blue cable. So, we were again offered the option of manual or automatic control. We chose manual. Let's see what the tester outputs. When connected with a red-blue cable, the entire firmware of this actuator is read, that is, all its parameters. Therefore, it takes quite a long time, compared to connections to other actuators, but nevertheless, it is also not that much. So we can see the following inscriptions here. Well, some of the inscriptions are already familiar to us. This is the control, that is, the position in which we want him to stand. In this case, the tester gives the initial position, this is 50%. We see that there are dashes here. This means that this type of actuator does not return its real position. That is, in this type of actuators, you can expect that the position that you have set, it also stands in it. Otherwise, if he does not stand in it, you will have a very high current, that is, he will try to put the actuator in the desired position. Your current will increase and a sound signal will be issued that the current has exceeded the nominal value. Well, known to us on-off, that is, the possibility of control or its absence, and also we have another inscription here below. So, for this type of actuators, we connect them with a red-blue cable. There may be three varieties of this inscription: PWML, PWMH, and also CAN. In this case, this actuator is controlled by a low-frequency PWM. Let's try to control them. That is, we clicked on the OK button, we have it here. So, we can control. And by moving the control knob, the actuator moves. When we turn it off, it goes to the starting position of 50%. Also, when the control mode is turned on or off, we can look at the firmware of this actuator. That is, what type of firmware, what number of the actuator. To do this, it is enough to rotate the handle to the right when writing of. So, we have the following menu coming out. Serial number 73031, the firmware that is stitched here is G066. This firmware says about the lower part of this actuator. That is, each letter G corresponds to its own type of turbine. Stop 1 and stop 2. So, stop 1, we have written that 10 degrees are programmed here. Stop 2 110 degrees. The letters are indicate that this data has been read. If we didn't change anything, then here we have letters W the same 100 and 110. Letters R and W are read and write. That is, this is what we have read, and this is what we want to write down. If we are not satisfied with these angles, or we want to adapt this actuator to a specific turbine, we can change these angles. How is this done? You click on the OK button. You get an arrow, instead of which you can change. That is, for example, we want to change the starting angle, yes, that is, the top one. By rotating the handle, we can change this angle. For example, we want to set the initial angle to be 30 degrees. One more click, the arrow moved into the next item. Let's say from 30 to 40 degrees we want this actuator to walk. And also the question is asked whether to save this data or not. By default, there is an option not to save. But if you want to save, you turn the knob, the inscription wound appears, that is, run. If you click OK, the tester will automatically overwrite these angles. If you don't need it, you can return the no. And one more click, you have started the process of recording angles. The recording process, it goes as follows. Letters disappear, dots appear, indicating that a certain process is going on, and as soon as the recording process is finished, the inscription OK will appear and the arrow will disappear. That is, now you have sewn corners that are 31 and 100. Why not 30? So, there is a kind of scale. Well, you can't clearly get there at 30. There, for example, will be 30.7 degrees. Accordingly, the actuator stitches the closest to the value that you set. That is, in this case, it is 31 and 100. That's it, these corners are programmed. Now we have an actuator that can only move in this range. We are going up, but we are not starting to control again. The value of the control, they were from 5 to 95, and they remain. But the range in which the actuator will run here has changed. Let's go back to the original value again to leave this actuator in the state it was in. So we had 1010 here. There were 110 here. Yes, 110. If you don't want to change anything, then when writing well, you can just click on the button and it will allow you to return to the previous menu. But we want to change, so we click the safe again, the process of recording the angle occurs, the inscription OK appears and we see that the angles have changed again. That's it, corner programming is over. I'll run through the menu again, in order to imagine where everything is. So, there are standard actuators here, quite common. There are actuators that, in principle, are similar in type to the others, but there are no lists of them. To do this, you can select the option Other, go into it and see the following menu. Type A, Type B, Torque Motor L, Torque Motor H. So, what is the difference between Type A and Torque Motor? So in the Type A variant, you can, well, Type A and Type B, you can test such an actuator of this type. This actuator has been Honeywell, it was not in the list, but at the same time you have selected a menu and in this menu you can use a universal cable and connect to the actuator. The rest of the menus are similar. Torque motor. There are such actuators, called torque motors. They stand on Volkswagen cars of some, as well as the Sonsbos firm of which. Well, we have the Sonsbos option, yes, here are the Sonsbos functions, but there are options on Volvos and on Volkswagen that are not signed. That is, in principle, it can be tested in torque motor mode. For more detailed information, you can refer to our YouTube channel, where you can find a specific actuator and how to test it. That is, we will not stop at this now, I'm just saying that there is such an opportunity. Basically, my review is over. If you have any questions, you can write to our technical support, or contact the managers from whom you purchased this type of device and we will try to answer all your questions.